So the chief guest of our inaugural session, Dr. Manju Balaji, Director, Khalsa College of Engineering and Technology, is already with us. She has joined the session. I welcome you, ma'am. So before the formal declaration of the FDP Open, let me introduce to you myself. I'm Dr. Ripin Kohli, coordinator of this online 6 days ATAL FDP, which focuses on the integration of cutting-edge technologies to revolutionize traditional manufacturing processes with the key aspects of core pillars of industry, applications in modern manufacturing, challenges and solutions, and future prospects. So moving towards the introduction of our esteemed institution, established by legendary Khalsa College Charitable Society in 2009. The college has rapidly grown. I request all the participants to kindly mute their mics. College has rapidly grown to become the institution of choices for students in Amritsar who are interested in earning a technical degree. Our society is 132 years old society which focuses on the quality technical education. So moving towards our chief guest of the evening for inaugural session, I request Director Ma'am Dr. Manju Bala to kindly address the participants in her speech. Ma'am, over to you. Ma'am.
Yeah. Am I audible?
Yes, ma'am, you are audible.
Yeah. Okay. Good evening to all. It is with the immense pleasure today to welcome all of you on this ATAL online faculty development program on advancing smart manufacturing, building the unlocking the power of industry 4.0 for the modern application. So today we embark on an exciting journey to explore the future of the smart manufacturing, focusing on the cutting edge technologies and their integrations into the modern technology. So I extend a very warm welcome to all of you today in this faculty development program. From the your presence underscore the diversity of this faculty development program, which I can see today. Almost 148 participants, those are going to join today. And the participants from the various reputed organizations like NITs, NIT Delhi, Jalandhar, Hamirpur, Kurukshetra and Patna, NITER, from the other PSG College of DAV University, Deviate, Jalandhar, Quantum University, Guru Nanak Dev University. So I can see there are the participants today, those who have joined from the various organizations for this faculty development program. And I hope this faculty development program will definitely be benefited for all of you. And you know, at Khalsa College of Engineering and Technology, be dedicated to fostering an ecosystem that encourages the knowledge exchange and between the diverse programs in the science and technology. And this FDP is the example for the same. And I would like to extend a very resource persons during the development program, and also my gratitude the ATAL AICTE Academy for providing the platform for us, which can enhance the learning of the various or you can say there is a commitment between all the organizations to share their knowledge and exchange their ideas during this faculty development program. Once again, the development program will definitely be successful and benefited for all of you. Thank you.
Thank you, ma'am, for your motivational words. So, moving towards the bit of the that what kind of incoming 6 days, I have already shared the schedule with you people. So, I acknowledge here the support of AICT ATAL Academy for granting us this opportunity so that we can arrange this FDP for the young minds. So in today's sessions, we will be meeting two of our resource persons, Dr. Narendra ji and Mr. Nadeem Pasha. They will be joining us shortly. So we have along with us Dr. Atul Agnihotri, who is Dean Research and Development of Khalsa College of Engineering and Technology. Sir, are you there? Am I audible? Dr. Atul? Dr. Atul? I think there is some network issue. So our next our speaker for the today, he will be joining us very shortly. Kindly be online. I also acknowledge here the presence of co-coordinator of this FDP, Dr. Khushleen Kaur, Assistant Professor, Department of MBA, Khalsa College of Engineering and Technology. Also, I guess all the participants are well aware about the rules, about the conditions of this FDP, that 80% of attendance is mandatory. And at on the very last day, there will be feedback and online feedback session and online test in your respective portals. The link will be shared and you have to appear in that exam so that you are eligible for the certification. So we have along with us the very first speaker of our day, Dr. Narendra Kumar ji. So Dr. Narendra Kumar.
Hello, am I audible?
Yes, sir, you are audible. Can you please switch on the camera, sir, please, if it's possible?
Actually, I'm checking my setting actually.
Yes, sir.
So,
Yes, sir.
okay,
So we have Dr. Narendra Kumar. Welcome, sir.
thank you.
He currently holds the position of Assistant Professor in Department of Industrial and Production Engineering at NIT Jalandhar. He is recipient of prestigious IEI Young Engineer Award and Best Teacher Award 2024 by NIT Jalandhar in recognition of his contributions to the field of production engineering. With over 12 years of experience in both research and teaching, he has also secured funding of rupees of 100 lakhs. I request all participants to kindly mute their mics. He has also secured funding of rupees 100 lakhs for pursuing research on 3D printing from ISRO, BIS, and SERV. Prior to his current role, Dr. Kumar served as an assistant professor in mechanical engineering and technology at ATAL, Ambedkar University, Jalandhar.
मैम आपका माइक म्यूट हो गया है प्लीज
Not audible, ma'am.
Yes. Am I audible now?
यस
Yes,
मैम
ma'am.
I'm sorry. So, prior to his current role, Dr. Narendra Kumar served as an assistant professor in mechanical engineering department. He also held the position of research associate at PDPM, Indian Institute of Information Technology. He has more than 50 research papers in his name in journals of national and international repute. His research interests span a wide spectrum, including CAD/CAM integration, rapid prototyping and tooling, additive manufacturing, and material development and characterization in manufacturing. I welcome you again once, sir. And over to you, sir. You please may start with your session.
Okay, so thank you, Miss Nipin Kohli, ma'am, for such a nice introduction. So, very good evening to all. I hope I am audible to all of you.
Yes, sir, you are audible.
Okay, so just, ma'am, give me a couple of minutes. Okay, I'm just going to share my screen.
Sure, sir.
So, I hope my screen is visible to all of you.
Yes, sir. Screen is visible.
Okay, so thank you so much. So, very good evening. So, as you know that the topic of today lecture is the next wave of manufacturing, embracing Industry 4.0, right? So, First of all, I would like to thank all the organizers for inviting me for this particular lecture. And here I am going to cover the topics like the evolution and relevance of Industry 4.0, right? And what are the core technologies of this particular industrial revolution? So in which I am going to cover about the IoT, AI, big data, 3D printing, AR, VR, cloud computing. And also I am going to discuss about the different applications of the Industry 4.0 is the industries, how they have benefited with Industry 4.0. So that I will discuss, right? And their benefits. And if we go for Industry 4.0 right now, what kind of challenges we will face? Okay, so that I will be talking, and then some future trends. So let me start with Industrial Revolution, right? So before I start, I would just ask you to imagine a factory, right, where machines talk to each other and they themselves predict failures before they happen. Okay, and they customize product for individual customers. And all this is happening without the human intervention. So I'm not talking about the any science fiction movie. This is going to happen in reality, right? In future. Like we have seen, I think in the newspaper that Tesla has, made a car, right? Self-driving car. Okay. So they are making, or they are, I mean, so, making cars which are powered by AI and IoT. So basically, this is the essence of Industry 4.0. It is revolutionizing the way we think about manufacturing, right? It is not the conventional manufacturing. It is, you can say, the revolution where the most of the things will be carried out in automatic manner. So let me start with industrial revolution first, right? What is this? And then slowly we will try to understand what is Industry 4.0. So industrial revolution can be defined as the major changes and transition in manufacturing and industrial process with new innovative technologies, right? So if you look at the previous revolution, right? Because now we are going to talk about industrial revolution 4.0. So what about the first industrial revolution, or the second industrial revolution, and third industrial revolution? So we will go through the definitions and the features of each industrial revolution to understand the Industry 4.0 in detail. I request all of you, please mute yourself. So here you can see that I have covered all the industrial revolutions, right? Like first industrial revolution, second industrial revolution, and third industrial revolution, and fourth industrial revolution for their level of complexity. So on the right side, you can see the level of complexity that can be achieved. Okay. So in the first industrial revolution, the level of complexity was not that much high. Okay. The products were too simple, and it was started with the mechanical production machines powered by water and steam. So it was happened around 1784. So around end of the 18th century. And the second industrial revolution, it was begun around the It was beginning around the 1870, right? So the introduction of the production lines actually powered by electric energy was carried out. Okay. And in the third industrial revolution, it was happened with the help of electronics and IT related, equipments or items. So it was started around 1970 to achieve the autonomous production, right? But when I talk about the fourth industrial revolution, the industry 4.0 word, was coined in 2011 in Germany, right? And what it is? It is kind of industry where we will have the cyber physical systems. So it means the physical products or the physical, or the components will be connected together with the help of internet. So the application is the smart factory, sustainability, right? So these things can be achieved through this industrial revolution, right? So before moving into the industry 4.0 in detail, first let us discuss about the current manufacturing practices. Okay, so let us have the overview of this current manufacturing practices. So currently what is happening? Currently the focus is on the mass production, right? And companies are trying to produce identical products in large number of quantities with limited flexibility. For example, if I go to market to purchase the pair of shoes, right? They have the shopkeeper, might have the the different pairs, right? But all are having the identical shapes like number 9, number 10, size number 10, 11. Okay. If suppose the customer wants to make the wants customized shoes, the shopkeeper will not able to provide that because companies are not, focusing on the customization. So the current focus is on the mass production, right? Second is the linear workflows. Currently, most of the processes are sequential, right? And they have basic automation at various stages, or sometimes manual intervention is required, right, to fabricate the components. And third one is the reactive maintenance. So most of the machines got repaired after the failure only. So once suppose bearing is not working, then we go for the replacement, right? So it leads to the unplanned downtime and higher cost. And if I talk about the quality inspection, inspections are often manual or semi-automated. So making them prone to errors and inefficiencies. So now let us talk about the challenges faced by the traditional practices. First challenge is the global competition, right? Because nowadays, due to the availability of internet, or you can say the the manufacturers, are setting up their plants in various countries. So it is increasing competition between the manufacturers, right? So they have to produce their components at lower cost and with superior quality. So global competition is one of the challenge. Second is the customization demand. So now consumers are demanding about means demanding the customized products like customizable footwears. It sometimes it may be electronics, right? And third one is the resource wastage, because companies are not, sometimes are not able to identify the requirement, the right current requirement about the production. So sometimes they overproduce the components, right? So in this way, they waste the resources of the company, right? And it affects the profits and sustainability, as energy is involved in the production, material is involved in the production. And fourth one is the limited data utilization, right? So many traditional factories operate without harnessing real-time data for decision making. They are not able to extract the exact data about the production, about the customer demand, right? Because they are not having any connection among each other. And last one is the environmental pressures. Industries face rising pressure to reduce their carbon footprint, right? So in order to overcome the challenges of the traditional manufacturing practices, now we are slowly moving toward the industry 4.0, right? So what is this industry 4.0? It is a new phase of manufacturing, or you can say the production, right? That introduce the intelligent networking of machines and processes for industries with the help of information and communication technology. So what does it mean? It connects physical worlds with digital world. How? Just by integrating the various core technologies like AI, IoT, data analytics. So by using these technologies, they interconnect the various systems and enables the real-time monitoring, adaptability, efficient production processes. Okay. Now the question is, why now only? When all is going well, right? Then why we are talking about the industry 4.0? So first one is the technological advancement. The reason, because nowadays a lot of research has been done in the area of IoT, artificial intelligence, cloud computing, even though robotics uh, have matured, right? So these things actually making possible the smart manufacturing of the components. So this is the first reason, because we are on the technological advancement stage, right? Second is data explosion, the rise of big data, because nowadays we all are dealing with data, right? We are creating a lot of data, and so which enables the advanced analytics. Whenever we purchase anything from the the uh, from Flipkart or Amazon, what we do, we initially check the feedback, right? And when we purchase it, Flipkart also ask us to write the feedback or review about the product. So this is also one kind of data, right? So everywhere, I mean, customers are generating data, and also companies, they can tap this particular thing, okay, for the manufacturing purpose. So the rise of big data enables advanced analytics for decision making and process optimization. The third reason is the market demands. So what customers are expecting today? They are expecting customization in the products. So I have given you one example of the shoes. right? And they are also looking forward toward the high quality products. But those products should be delivered quickly and cost effectively. So in order to cater this particular demand, we have to go for the advancement of manufacturing, right? Now the next is the global competition. So in order to keep themselves in the profit stage, manufacturers need to adopt smart technology. Then only they can stay themselves competitive and agile. Okay. Then next reason is the sustainability. Industry 4.0 supports the resource efficient and eco-friendly operations. As I told you in the previous slide, in this slide, about the environmental pressures, right? Their industries are having pressure, right, to reduce the carbon footprint. So sustainability, I think, is one of the reason. That's why they will be moving toward the industry 4.0, because industry 4.0 supports resource efficient and eco-friendly operations. So in this way, it aligns with the global sustainability goals. Then next is resilience. Post-pandemic challenges highlight the need of flexible, automated, and digitized supply chain. So obviously, this can be achieved through the Industry 4.0. And last reason is the cost reduction. So in Industry 4.0, as it promotes the automation of the systems and the predictive maintenance, so these things reduce the operational expenses. So if cost is reduced, obviously we can reduce the
Sir, your mic is now mute, sir. You are requested to unmute yourself, sir. Sir, you are requested to unmute yourself.
ma'am, somebody is doing it because I have not done anything. Somebody is changing the setting of the this particular meet. I don't know who is changing, but I have not done anything yet.
Maybe, sir, some kind of glitch. You may continue, sir, please.
Okay, thank you. Okay, so whether I was audible is on this slide or not?
Yes, sir, you were audible for up till this slide, sir. You were audible.
Okay, okay. So now what are the core pillars of Industry 4.0? So we will talk about the different pillars of Industry 4.0. So you can see some of the pillars here. First one is the IoT. Second one is the AI and machine learning. IoT means Internet of Things. Second is the artificial intelligence and machine learning. And third one is the big data analytics. And fourth one is cloud computing. And then we have augmented reality and virtual reality. Right? Augmented reality and virtual reality. And also we have another pillar, that is additive manufacturing. It is also known as 3D printing. Then we have cyber physical systems, right? That help us to integrate the physical and digital systems on the broad scale. So now let us start with the IoT, that is Internet of Things. Okay. So Internet of Things basically is a network of physical objects. Network of physical objects that are able to collect data with the help of sensor and exchange data each other with the help of internet. So let us take an example of a smartwatch. So here I think you can see that here this smartwatch, is measuring the body temperature of the user. So what IoT is how we have incorporated IoT in this. For example, this watch is measuring the body temperature high. So it is indicating body temperature high and it is asking to book the doctor appointment. So can I book doctor appointment? Right? Yes or no? If the user tap on the yes button, what will happen? This smartwatch will automatically call the hospital on the given number. Right? If the body temperature is high, this smartwatch will automatically either send the message for the appointment or it will initiate the call. Right? And after that, immediately the patient or this user will talk to that doctor and ask for the appointment. So how it is happening? Because of the internet. Okay. So hospital basically is thing. Smartwatch is also a thing, right? And we have connected them by some interface or with the help of internet. So it is helping the user in the appointment. So that's why I have defined it as it is a network of physical objects that are able to collect data with the help of sensors and exchange data each other with the help of internet. So how hospital and smartwatch are exchanging data? Obviously with the help of internet. So how now the question is, how can we use this IoT in the manufacturing, or how it will help the industries, okay, in the manufacturing of the products? So IoT basically enables the machines, devices, sensors to communicate and share data in real time so that the user or the operator or the industries can take decision with better insights. So it helps in the device connection, right? And also in the real-time monitoring. So sensors collect data on the production processes and allow the real-time monitoring and analysis, right? And also they can identify the potential issues before they arise because they are collecting data. So based on that data, user or industry can take the decision. If any potential issue is there, they can either go for the productive maintenance or for the stoppage of the production. And third benefit is the remote control. So machines can be remotely controlled and monitored, enabling efficient management and optimization of the production line. So because machines are connected with each other, so if one machine is having some downtime, right? So that machine can inform to the next machine. So machines can talk to each other. Similarly, factory to factory communication. Within factory, machine can communicate each other, and then on the large scale factory, suppose some factory number A is having the overproduction or the overburden, then that factory can share that data with the another factory where we have the production machines in the idle condition. So they can initiate the production, right, of the particular components. So this is how we can use IoT in the connectivity of the different machines and the factories, right? Then next is the artificial intelligence and machine learning, because we nowadays uh, we all know the use of artificial intelligence. We can use AI for some positive things, and also on the other hand we can use it for the negative things also, right? But AI can help in the achieving of the industry 4.0 goals. So what is AI? We will try to understand first, and how it can help us in the industry 4.0, that we will see in the subsequent slides. So AI is nothing but a computer program, right, which enables a machine to simulate human behavior like learning, planning, reasoning, knowledge sharing, problem solving. So here I have taken one example of Siri or Google. So when we ask anything to Google, right, or hey Google or hey Siri, right, immediately it try to decode the voice and act. For example, if I ask to Google open some website for me, it will immediately open it, or it will change the setting of the device. So similarly, basically this is also the application of AI. And what is machine learning? Machine learning uses a data-driven approach, right? That is typically trained on historical data and then used to make prediction on new data. So machine learning is all about the data, or we train the different models by using the existing data just to get some sort of trends, new trends. So this also help in the industry 4.0. Now, how can we use it in industry 4.0? So the first one is the predictive maintenance, because maintenance is also one of the uh, predictive maintenance is one of the, because I just explain you with the current manufacturing approaches, what we do, we go for the reactive maintenance. We go for maintenance after failure. But in industry 4.0, predictive maintenance is one of the key feature. So with AI algorithms, we can analyze data to predict the failures, right? So if we get some information regarding the failure of the components, obviously we can minimize the downtime of the machines. We can reduce the cost of manufacturing. We can increase the production. The next is the process optimization, because as I told you that machine learning is all about the data, right? So machine learning algorithms can optimize the production processes, identifying patterns and improving efficiency. So for example, if you are aware with the milling process, for example, right? So in the milling, we use the various parameters like depth of cut, speed, feed, right? So if we have some data, past data about these parameters, and if we make any model, or if we train the model by using this data, right? This machine learning algorithms will help us in future. Don't use these setting, otherwise it will give you the rough surface, or they will suggest in positive way use these settings to achieve the better surface finish, right? Or to just reduce the build time. So this we can achieve with the help of machine learning algorithms. And third is the quality control. Quality control means AI powered vision systems, because nowadays what is happening in the market, now the machines are having some type of vision systems. So what they do, they scan the object which is under fabrication or manufacturing, right? And based on the condition of that particular component or the object, they take decision or they send signal to the operator. How it is happening? Because of AI. AI powered vision systems can detect defects in the products, ensuring quality and reducing manual inspection. So on the left side, you can see we have a vision system in the image, right? So it is scanning the box, right, which is moving from the line, okay, which is moving from one place to another place. So it is just scanning the the condition of this box, whether it is open one or the closed one. Accordingly, it will send signal to the user or the operator, right? And based on that, the user will take the decision. So this is how the artificial intelligence and machine learning can help in achieving the goals of future manufacturing or the industry 4.0. The next one is the cloud computing. So we all know about the cloud service which is provided by Google. So we all know about Google Drive. Most of us know about the Dropbox, right? OneDrive is also there from the Microsoft. So what they are doing, they are storing the data, right, on the cloud. So cloud computing basically is the use of remote server to store, manage, process data which can be accessed through the internet on demand. Sometimes what I do, I generally save my data in the Dropbox, right? So I have installed Dropbox in my PC as well as in my laptop, right? So whenever I save my file in Dropbox in my PC, I just open my laptop and I access that file through my laptop also. How it is happening? Because of the internet. Now I am not using any pen drive for the data exchange. I am using these cloud services. So similar to this, industries can use this cloud computing. Because what I told you about the this industry 4.0, industry 4.0 is all about the cyber physical systems, where we will connect all the physical systems with the internet. So when multiple systems will be connected through the internet, obviously we will have to uh, manage or store or process data in the cloud uh, storage way. Okay. So it may help in the scalability, right? Scalability means because all data is in the cloud. So on demand resource can be arranged with the cloud computing as per the change in the need of the industry. We can access data, right? Second advantage is the cost effectiveness. Because as I told you, I'm not using pen drive, right? So there is no physical system involved now in the data exchange. So similarly, here company can use the cloud computing to reduce the cost that is involved in the IT infrastructure. And another advantage is the collaboration. Cloud platforms facilitate collaboration and data sharing across the teams and departments, because in industries we have many departments, right? Quality department is separately basically established, and then production team is there, market, department, marketing department is there, sales. So there are various departments, right? So if all data is on the cloud, it can be accessed easily by the different departments and the teams. And also the cloud computing enables access to advanced computational power for complex tasks like simulations, machine learning, data analytics. Okay. So for example, if I take an example of this, automotive manufacturers can scale up computation resources in the cloud to run the simulations for crash testing or AI models for predictive maintenance, right? And also one more advantage, according to me, is the global reach. So cloud providers have data centers worldwide, like for example, Google Drive, let's say, or the Dropbox. They have data centers worldwide, okay, allowing businesses to scale operations globally. So in this way, we can increase our reach globally without setting up infrastructure in each location. Okay. The next pillar of Industry 4.0 is the augmented reality. Augmented reality, right? So what is this augmented reality? It is a technology that create enhanced version of a real world in front of us by adding a layer of digital information on that. So what we do under augmented reality, we use digital information on the top of physical object, right? So digital information is overlaid on the top of the physical objects using, for example, device camera. So as user move their devices, the AR overlay updates in real time. So for example, if I open my mobile camera and if I focus it on the some object, it will give me the information as you have seen in the Hollywood movies, right? And what is virtual reality? Virtual reality is the use of computer technology to create a simulated environment. So by using this technology, you can change the way of the education or the manufacturing. I will tell you how can you use these two technology in Industry 4.0, right? Now, what are the differences between AR and VR? VR is the computer generated graphics, as I told you. Here, what we do, we use digital information on the top of the physical objects, right? So VR, AR is the AR is the computer generated graphics on the top of the actual reality, and VR is the computer generated graphics to create the entire virtual world, as you can see in these two images. In the first image, you can create the entire environment of Mars, right? Surface. In the second image, you can see that here there is student, right? We just imagining the sun in front of him. Earth is there, which is revolving around the sun. So these kind of things can be created to simulate the entire virtual world. Now the question is, how can we use the AR/VR application in Industry 4.0? So AR/VR can be used for the training and skill development. So AR provides the immersive training environments where worker can learn complex processes without risk, because we can create that particular environment virtually. So without risk, we can train the workers, we can develop some sort of skills in the workers. So for example, if I take an example of the production line, virtual assembly training for operator on the production line can be done. Second thing is the maintenance training for engineers. So with the help of AR and VR, we can allow them to interact with 3D models of machinery in real time. Okay, so by using this technology, we can train the workforce, right? We can focus on the skill development of the workers. Second is the maintenance and repairs. As I told you, AR basically overlays the digital information on the top of the physical objects. So AR overlays instructions, diagrams, and real-time data on the physical equipments. So in this way, we can guide technicians through repair or maintenance tasks. Right? So for guiding purpose, AR can help us. So just technician will wear the glasses, right, and can see the step-by-step instructions superimposed on the machine to replace the faulty parts. Right? And third is the quality control and inspection. Quality control and inspection. So what is this quality control and inspection? AR enhances the quality assurance by visually comparing the manufactured part with the digital models. So whatever inspector is there in the shop floor, they can use the AR devices to identify the defects in the products by just overlaying design specifications on the actual items. So this is how the this technology can help in the manufacturing, or how they can help in the industry 4.0, right? Another aspect of this particular technology is the product design and prototyping. So it enables designer to visualize and interact with 3D models of products in real space before physical prototypes are made. Have you seen this feature on Flipkart? Anyone? This AR enables customer also to visualize the product in real space or in the room, right? Before purchase. Have you experienced this thing ever? Anyone?
Participants are requested to kindly respond, please.
Have you ever experienced
Not
the AR
yet, sir.
application? Huh?
Not yet, sir.
So, okay, have you ever purchased anything from Flipkart or Amazon? Flipkart, because I know they have introduced this feature.
So there is one response that many times on NICA website too. Of course.
Yeah, because nowadays what companies are doing, they are using this technology for this purpose. So now before order, customer can check the product, right, in real time. Sorry, in real space. In real space. For example, if I order a TV from Flipkart, right, I can check it, how it will look like in my
Yes,
room.
sir, it has been shown in Amazon. You can
Yes, yes,
place that any.
because I know because that specs company. Uh, I'm not able to recall the name of the company, right? So that company used the AR
For
technology first.
super,
Which
good
one?
evening, sir. Sir, in case of lens card, we can use the
Yes,
QR.
yes, lens card. Yes, lens card. Yeah. Actually, I forgot the name of the company, right?
जी जी
Lens card actually started, I think, first time. I think so because according to my knowledge, right? So they started this thing first, and later on, the Flipkart and Amazon they have introduced this technology as well. So these things, because now what company are doing, they are giving flexibility or they are giving this uh, you can say the facility to their customer so that they can check the product before order. Otherwise, what will happen if they don't use this technology? Customer will return the product if he does not like or she does not like the product. Right after delivery, what will happen? They will return the product and they will get the refund from the company. Okay, so it will unnecessarily add the multiple steps in the supply of that particular item. So company, that's why they are investing on these things. So similarly, industries can also invest on these technologies. They can train their workers, their workforce. They can develop some sort of skills by using these technologies. Okay, so another advantage which I guess, that is assembly and manufacturing processes. So AR improves the accuracy and efficiency by providing workers with visual guides and real-time instructions during assembly, right? So assembly means can be eased with the help of this particular pillar of this industry 4.0, and it can also simplify the inventory tracking and navigation in the warehouse. That is also very challenging. If suppose you go to any warehouse, right, where it is very difficult to find the correct size of nut and bolt. If you just visit any small MSME, right, they their inventory is not sorted and they just store their inventory here and there. So if you try to find anything right from their warehouse, it will be very difficult for us. So this AR technology simplify the inventory tracking and navigation in the warehouse. So they can highlight the location of a specific item in the warehouse, right? Workers can view the inventory level and the detail by scanning the shelves or the barcodes. So this is how we can, right? And one more thing which I've already shared with you, that is the customer experience and marketing, which are already being used by Flipkart and Amazon and the Lenscart, right? So AR can enhance the customer engagement because ultimately we are producing the products for customers. If they do not like it, there is no use of the product, right? Obviously, company will mean loss. So AR can enhance the customer engagement by allowing the user to interact with the products virtually, right? So this is how the customer can visualize the product in their homes by using this technology. Then next is the big data analytics. Big data analytics, right? Big data analytics means it is a process of store and examine large volume of data. Large volume of data. So here some activities are there which are covered under this particular pillar. So first is the collecting data, right? Cleaning data, and then we have the analyzing the data, right? So key feature generally of these big data indexes are the volume. So it handles the large data set generated by the machines, sensors, and the IoT devices, right? Second is the velocity. It processes the data in real time. Because if we are not, getting the data processing in real time or near real time, then we cannot take decision quickly. So in order to enable the quick decision making, this processes the data in real time. Okay, about the failure, about the production, anything, because data set is very, very important. Variety. So it analyzes the structured and unstructured data. So for example, sometimes we can get data in numbers. Sometimes we can data from the vision sensors in terms of images, video, text. So a lot of variety is involved there, right? The next feature is the veracity, that is ensure the reliability and accuracy of the data. And last is the value. So it converts the raw data into the actionable insight. So it present the data in such a way so that the user or the industry person can take the decision, right? So it help us in the data collection, data analysis, data driven decision. Okay. So application of the big data index in the industries are like predictive maintenance, right? So for example, using historical or real-time machine data to predict the equipment failure before they occur. So sensors in machinery collect vibration and temperature data. And this analytics identify the pattern, right, of the vibration, of the temperature, whether it is leading to the potential breakdowns or not. So it can help us in the reduction of downtime and the maintenance cost. And also it improves the equipment lifespan. Otherwise, one component failure may lead to the second component failure, or the bulk failure of the components may lead to the overall machine failure. So it improves the equipment lifespan. It also helps us to reduce the downtime and the maintenance cost, right? And second area where it can help in that is the supply chain optimization. So it can analyze data across the supply chain to improve the efficiency and to reduce cost, right? So real-time tracking of the shipments and inventory levels helps prevent overstockings and shortage. Okay, so this is second advantage of the big data index. And third is the quality control. So using data, we can easily monitor and improve the product quality. How? Cameras, as I told you, vision systems are camera, right? They can capture some sort of data in the form of images, videos, right? Sensors are there which can easily measure the process, easily measure the conditions, right, on the production line. Then after applying this particular technology, it can detect the defects by comparing all the data collected against the predefined standards. So in this way, it minimizes the defect and waste of the material, and it ensures the consistent product quality. Okay. And also one more area where it can help, that is the customer behavior analysis. Customer behavior analysis. So with the help of this data analytics, we can understand the customer preferences and behavior by just analyzing the purchase data. So all the companies are having their customer data. For example, Flipkart, whenever we open the Flipkart, right, they try to suggest some of the products because they have their your data. That's why they are suggesting few products, what you have purchased, what you have searched on the Flipkart. So accordingly, they try to show you some of the products. Okay, because they know the behavior of their customer. So in this way, company can improve the customer satisfaction. They can inform the the product design and marketing strategies, right? And another area where it can help, that is the process optimization. Means it can easily identify the bottlenecks and inefficiencies in the industrial processes. So for example, a factory uses real-time data to monitor the production speeds and identify slowdowns. So in this way, we can easily achieve the productivity enhancement and waste reduction. Then any other area also, that is the market trends and forecasting, because we collect data through this technique, right? And with the help of that data, we can predict future market trends and customer demands, right? Yeah. So next pillar of this industry 4.0 is the additive manufacturing, or people know this particular technology as 3D printing, right? So that's why I have used this particular, uh, name here also. So I will take a separate lecture on this technology on 8th of January, right? So this is a technology where we create three-dimensional objects from a CAD model. Do you know what is CAD model? This digital 3D model? Anybody? I assume all are from mechanical engineering background or the production
Sir,
engineering background.
we have diverse backgrounds, engineering and management, both backgrounds.
Okay,
So
that's why I'm asking, because if I know my audience, right, then I
yes,
can change the pattern of my lecture.
okay, sir. So we have diverse backgrounds here from also we are having from
Okay.
management department.
Okay, ma'am. Thank you. So here,
So as far as CAD model is concerned, it is a software, CAD software, which is used to make 2D or 3D models that are further used for designing and manufacturing purposes.
okay, thank you so much. So CAD model means computer aided design, right? So with the help of computer, we can, for example, uh, as we make drawing on the drawing paper sheet, right? Similar to that, what we can do, we can create any 3D object virtually in the software. So whenever I will cover a detailed lecture on this technology, that time I will try to cover this also, right? So it is a technique where we manufacture three-dimensional object from a CAD model. So CAD model is nothing but a virtual 3D model, right? That has been created in the software. So that's why this technology is also known as 3D printing, because we directly
So why
use
the name
3D.
printing?
Yeah.
Why printing is used?
Yeah,
Why
that's
the
why I'm
name
saying,
print?
just explaining, sir. See, in 2D printing, what we do, we prepare a document and we just use print command, right? So that paper, that text or document is basically is a digital document, right? Once we press the print command, our paper printer is automatically started, right? And it starts the printing process. It automatically collects paper from the tray, then printing is started, then finally it comes out from the printer. So this is the process of 2D printing, right? 2D means simply you have a document and then you are just pressing the print command and you are getting the output in terms of the paper, right? So similar to that, here what we do, we prepare a CAD model. CAD model is nothing but a 3D model that is created in the CAD software, that is in the computer, right? So we can directly use this model or we can feed this model in the machine, and machine will start, the manufacturing of that particular 3D model by adding material in the layer by layer manner. So here what we are getting? We are getting 3D object from the 3D model only. No special tooling is required. No jigs and fixtures are required. So that's why this technology has become very popular with the name of 3D printing. I think I know now you got the answer of your question query.
Yes, sir. Thank you.
Okay. So similar to the paper printing or 2D printing, we can create the objects in 3D. No special tools are required. Just we press command and machine starts printing. Okay, or the depositing the material. So we can add material such as plastics. We can also add materials, liquids, right? We can also use powder form of the material in the powder form. So various techniques are available. I will cover a separate lecture of this on the day after tomorrow. So no worry, I will cover it later on. Now let us see the role of 3D printing or additive manufacturing in Industry 4.0. Why we are focusing, why our focus is on the additive manufacturing or 3D printing? Because it reduces the lead times. Lead time is the right from the order given by the order is made by the customer and the time when we are delivering the product to the customer, right? So with 3D printing, we can reduce the lead time because I have already explained to you that in 3D printing, no special tooling or any support jig and fixtures are required, right? And second thing is it promotes on-demand production. It promotes on-demand production. On-demand means whenever customer is demanding for the customization, for example, for the customized product, we will simply make the CAD model in the software and we will press the print command. Right? Ma'am, some disturbance is coming from your side, so please fix it.
Done, sir.
Okay, thank you. So reduce lead time and on-demand production. Second advantage of additive manufacturing in Industry 4.0 is that decentralized production and localized 3D printing hubs. So what is the meaning of decentralized production? Now what happens whenever we we purchase anything from the market, right? And if you try to check their manufacturing plant, right? Or if you try to check the details of the manufacturing plant, you will find most of the manufacturing plants are in Delhi, in Bombay, or in the Kolkata, right? From where we are getting all the products, right? Through the proper connected supply chain or network. But with 3D printing or additive manufacturing, the production can be decentralized. Why? Because we can establish localized 3D printing hubs nearby to our cities. So whenever there is a requirement of any product, right, we can approach to those hubs, and those hubs will work on the demand, or accordingly they will make the CAD model and they will give the product to you. Okay, in your hand. So this is another feature of the additive manufacturing. Third one is the customization and personalized products. Due to the advantages of 3D printing, such as no tooling is required, right? No jigs and fixtures are required. Every time we need to customize the CAD model for the customer, right? To cater their customization demand. So customized and personalized products may be supplied easily, and also it simplifies the supply chain and reduce the reliance on the intermediaries. So it simplifies the supply chain means, because I told you we can establish localized 3D printing hubs nearby. So we can simplify supply chains in this way. On-demand 3D printing of spare parts. Spare part means suppose any downtime or breakdown is there, so we can easily order the spare parts, or we can place order for spare parts to localized 3D printing hubs. So on demand, that can be fabricated. And one more thing is that is very, very important. It also reduces the waste material, right? If I talk about any other manufacturing process like milling, like uh, casting, lot of material is wasted, right? Because in the machining, we have to remove the material in the form of chips to get the desired geometry, right? But in 3D printing, because we add materials in the layer by layer manner, right? So wastage of material is reduced, which promotes the sustainability. And another advantage is the faster product development and prototyping, right? Because no special mold making is required. So obviously we have opportunity to make the develop product at faster rate. Then design freedom, I think one of the key feature. Design freedom for complex geometries. And also the product optimization. It is one of the key feature. That's why this technology will become the major pillar of Industry 4.0. I will show you some of the components that cannot be fabricated by any other manufacturing process. If suppose additive manufacturing is not there, right? We cannot even think about the manufacturing. Or if you think, then it will take time of 1 year or 2 years. Still accuracy will be concerned. So here with additive manufacturing, the complexity can be achieved. This is one of the key feature, because in my very initial slides, I have shown you the level of complexity. I have compared all the revolutions, industrial revolutions, for the level of complexity required in the products. So it is increasing day by day, or I can say decade by decade, it is increasing. For example, if I take an example of a mobile phone, 20 years back, right? 20 years back, the mobile phones were very simple. They were having only the keypads and small screen, right? No camera, nothing. But now, if you check all the features of the mobile phone, you will find the big screen, better touch quality, good camera, right? Other sensors are also available to just to give the facility to the user of the mobile phone. So if you look at any product, either it is related to the automobile, it is related to the the electronics. Let's say example of smartwatch. 20 years back, no smartwatch available, right, in the market. But now, even though watches are very smart, right? They can check your body temperature, they can check the heart rate also. So they will give you, the idea how much distance you have traveled so far in a day, right? You can feed some of the, you can also, check your activity, monitor your activities. Accordingly, you can take the action, what action is required further. Suppose your smartwatch is showing you in the stress condition. Now you can immediately even take some uh, measures, right? So nowadays, all the all the devices or all the products are becoming smarter, right? Day by day, complexity is increasing day by day. So if you compare all the manufacturing processes, additive manufacturing is one of the process which is having capabilities to tackle these complexity, right? Those who are from management side, right? If you make any object, right, other than additive manufacturing. So let's say, for example, let us take an example of a simple product, that is the plastic mug. Although it is very simple, right? It looks very simple, but when we manufacture it, this will be very costly and very time taking, because for mug making, we have to manufacture the mold first. Mold is the cavity in which we will pour the, or we can say the supply the plastic material. So mold making, for simple one design, we have to make one mold. If we suppose we change any design, right? Or suppose I want to change the design of the handle of the mug. In that case, I have to go for the modification in the mold. But in 3D printing, if the product is too simple or it is too complex, no such tooling is required. So complexity is not a big deal now, right? So obviously the applications are in the rapid prototyping. You can quickly create the cost-effective prototypes for your design, or you can accelerate the product development, right? You can also go for the customization because it does not require any kind of tooling. So mass personalization is also possible with this. That is also the key feature of Industry 4.0, where the industries will focus on the customer preferences for the products. So customer preferences may be different, okay, for each customer. Then distributed manufacturing. So as I already told you that on-demand production. So 3D printing or additive manufacturing allows the on-demand production, okay, and reduce the reliance on the centralized factories, and it enables the distributed manufacturing as well. So cybersecurity is there because security is one of the big concern, because when we are connecting all the physical systems with the internet, so anybody who is the hacker, for example, they can misuse, right? They can uh, do some things in the negative way. So that's why cybersecurity basically is the practice of defending computers, server, mobile devices, electronic systems, networks, and data from the malicious attacks. So this is also one of the pillar that is needed. So now let me tell you the applications and benefit of Industry 4.0. First one is the manufacturing. So smart factories we can establish, right? Predictive maintenance is possible. I have already given the example of that. How can we do the predictive maintenance with the data analytics and the ER, VR? How can we train the workers, right? So in the manufacturing, it can help us in the productivity enhancement, reduction in the downtime, and the customized production. In the healthcare also, we have IoT enabled medical devices, right? AI driven diagnostics and telemedicines, right? Which can improve the patient outcomes, real time monitoring, and cost effective care of the patient. In agriculture, you can see the precision farming is possible with Industry 4.0. Drone monitoring and automated irrigation is possible, which increases the yield, crop yield, right? Efficient resource use and reduce environmental impact. And logistic, I think, is also one of the area where the Industry 4.0 can be applied. That is the autonomous vehicle. Real-time tracking will be possible due to data analytics, real-time data, right, monitoring. Blockchain for supply chain transparency. Blockchain again it's a component of cybersecurity, right? So this will enable the faster delivery of the products, cost saving, and enhanced customer satisfaction. So all because I have already shown you the application benefit of Industry 4.0, but here I have also mentioned the challenges and implementation strategies. What kind of challenges you may face in the implementation of Industry 4.0? So first is the high cost of adoption, right? Then cyber security vulnerability is are there, because security, as I told you, it is big concern, right? So we have to be very careful while we are connecting the multiple systems together. We are exchanging the information with each other. So cyber security vulnerability is one of the challenge, I think. Skill gaps in workforce, because we are talking about the AR, VR, data analytics, right? Additive manufacturing. These are the core pillars of Industry 4.0. So, but still, skills will be required. So the training is to the workforce is very, very important. But now, right now, there is a huge gap, right? I think most of the industries are in the country. They have not implemented, Industry 4.0 fully due to this problem, right? So here I have just mentioned the challenges in detail. So you can go through them. I will share these slides with you. So resources and cost constraints are there. And then for bridging the skill gap, we have to, invest in upskilling and reskilling program for the workforce, right? To equip them with necessary skills to navigate the demands of Industry 4.0. Okay. Then collaboration with the education institutions will be required to develop the customized training programs related to the Industry 4.0 skills into the workforce, right? And also overcoming resistance to change because nobody wants to change themselves, right? So here communication and transparency will be required to just overcome the resistance to change, right? We have to increase the employee involvement also, and proper training and supports will be required for the transition to new technologies and the work processes. So assessment strategies for successful implementation, assessment and planning. So initially, we can conduct a thorough assessment of the current capabilities. We can identify the areas for improvement. We can apply, the Industry 4.0 slowly with the some pilot projects. Then after, based on the results, wider adoption of these can be, done, right? And phase-wise implementation can be, promoted, and to just allow the workforce or the workers of the company for gradual adoption and minimizing the disruption of the existing operations, right? So here I have mentioned one of the case study from Siemens. They have benefited it in very good way because Siemens, this is very big company and they make products, uh, different types of products, right from the services to the building technology and to the actuator sensors. So they do a lot of things, right? So they applied this, Industry 4.0 in their industries, and they have benefited in positive way. So with this, thank you everyone for your time and your patience. So if you have any query or any suggestion, you please feel free to ask or share with me. Thank you. Thank you so much.
Participants, if you have any queries or any doubts or any questions, you can please may ask Dr. Narendra ji. Any of the participants?
Ma'am, just wait. I want to just show one of the video, right?
Yes, sir. Sure, sir. Sure, sir.
Just wait. Let me open my folder, right, where I have this video to give my participants a brief idea about this. Let me show you. Okay, so now I'm going to share my screen. Just all of you, please see this video. This is very interesting, right? This is very,
Sure,
very
sir.
interesting. And you will enjoy this video because this gives us the idea of what is this? Ma'am,
Our
are you able
world
to see
is
this
full
video?
of exciting ideas. Imagine every idea could be realized as an individual product in
Are you able to see this video, ma'am?
No, sir. Video is
No?
no, sir.
No, it is paused right now, but again
Visible.
I'm playing it.
It is visible.
Yes, sir, we are able to see it.
Automation beyond imagination to
And
make
audio,
this happen.
audio.
Yes, sir.
Audio.
Yes, so audio is audio.
No, I have shared audio as well. So are you
Before
able to
production can start, the order is analyzed
let me
to
play this
derive the
video
material.
again? Okay.
Our world is full of
So
exciting
participants
ideas.
can see both audio
Imagine
and
every
video.
idea could be
Okay,
realized
thank
as
you,
an
thank you.
individual product in the future. We at Siemens advance industrial automation beyond imagination to make this happen.
This video is by Siemens.
Before production can start, the order is analyzed to derive the materials and the processes needed to do the job. We also choose the most appropriate factory for the order in terms of available capabilities, supply chain aspects, and the best climate footprint. We envision that companies strive to produce only what is really requested, to be more economical, and to save valuable resources. After analyzing the priority of the unloading process, intelligent algorithms allocate suitable resources based on their offered skill set and availability. Huge amounts of data need to be analyzed in the production process, like the video stream of a drone that identifies the position of the supplied materials and checks the delivery for completeness and damage, all at the same time. However, not all tasks can be solved fully automatically. Human expertise and intuition are still crucial to make critical decisions in the autonomous factory. Intelligent systems are connected, exchange information, and collaborate to complete tasks quickly and efficiently. Tasks such as triggering material transportation. With the scanned information, the autonomous units know what to do and ensure a smooth unloading process, all without complex engineering of each process step. Each autonomous unit offers a set of skills. For the execution of a skill, workflows are generated on the fly by considering the environment and the given process goal. A variety of AI technologies are used to solve complex tasks, such as the unloading of a pallet in an automated way. All automated processes are continually monitored by certified advanced safety concepts for human-machine interaction. In rapidly changing environments, self-adapting safety functions are crucial to produce efficiently and, more importantly, safely. As customized products require individual manufacturing solutions, additive manufacturing allows for completely new shapes and forms hardly possible in conventional production. In our self-organizing production, autonomous units exchange information about their environment to collaborate in the real world.
Now the product check for quality.
If a production step cannot be performed by a single production unit, the intelligent production system divides the process into subtasks. Then it assigns production modules to them, even considering tool changes and transportation times. For even higher efficiency, a combination of flexible grasping and visual detection facilitates the handling of previously unknown parts. However, even a robust AI application can have its difficulties when minor differences are barely visible due to an unfavorable perspective. Whenever an AI system reaches its limits, it must be able to ask for human assistance. Based on human feedback, the system learns and improves continuously. The autonomous factory is more than just a vision. We at Siemens already support and experiment together with our customers to transform their production so that individual ideas can be brought to life. And RoboStar can win a small heart by storm.
So I hope now it is clear to all of you what is the future of manufacturing, right?
Yes, sir. Participants, I request you, if you have any kind of query, you please may ask, sir, or else we will be winding up the session. So, sir, I'm really thankful, first of all, that you spared your such valuable time, and your presentation dealing with Industry 4.0, and you started from the very basics, that challenges faced by traditional practices, and what are the Industry 4.0 is the new phase of production in the engineering, and you expressed everything in a very simple language so that all the participants could easily, I guess, grasp it. Once again, thank you so much, sir, and looking forward for your another session on the day after tomorrow.
Thank you so much, ma'am. I am really thankful to you also, because you have, listened my lecture, I think, in very good manner. And I try to cover, I think, basic aspect of Industry 4.0. What are the core pillars, right? And what are the challenges we are going to face in the implementation. So with this, I think it's all from my side, right? So if you have any query, then you can share my, email ID and mobile number with the participant if they want.
Sure,
Right?
sir. Yes, sir. On the very last day, we'll be sharing the details of all
Yeah.
the,
So day after tomorrow, we will
resource
have
persons.
again one lecture, right, on 3D
Yes,
printing
sir.
only.
Yes,
So
sir.
I will try to cover all the aspects related to 3D printing. So thank you.
Thank you so much, sir. Thank you.
Excuse me, ma'am.
Yes.
Ma'am, my name is Dr. Kumar from Purnima University.
Yes, sir.
Ma'am, actually, I haven't get any link for this session. So I get it from one of my colleagues. So I want to know whether I have registered to this program or not, because I have registered, but I haven't get any link.
Sir, did you register? You did register for, you might have registered on
Yes,
ATAL
yes.
portal, but did you apply for the FDP, sir?
Ma'am, may I leave now?
Hello.
Sure, sir. Sure, sir. Thank you so
Thank you.
much, Dr.
Thank you.
Narendra ji. Thank you so
Thank you.
much.
Thank you.
So
Thank you.
Lecture was very fantastic, sir. Thank you. Yes, ma'am, I have registered, but I haven't get any confirmation for this program. So I get.
you can contact Dr. Khushleen Kaur, who is the co-coordinator of the FDP. Okay.
Okay, ma'am.
Okay.
Okay,
So
ma'am. Thank you. Good night.